In order to do question number 1, we need to be aware of our place value chart. Here we have an 7-column chart. We would have our ones column, ones or tens or hundreds, thousands, 10,000s, 100,000s, and million. The number that we're going to be focusing, the numbers that we're going to be adding are 32,908, 98, and 66. Let's put those in our columns now. So 32,000 has 3 sets of 10,000, 2 sets of 1,000, 900, no tens, 8 ones. 98 has 9 sets of tens and 8 ones, and 66 has 6 sets of tens and 6 ones. Our operation is addition, so we'll put that there, and we'll begin to add the items in our column. So we would say 6 plus 8, 6 and 8 would be 14, 14 and 8 would make 22. So put our 22 outside, we're going to put down our 2 and carry 2. 9 and 6 would be 15, 15 and 2 would be 17, put down our 7, 17, we'll put down 7 and carry 1. 9 and 1 would be 10, we put down our 0, and we would carry 1. 2 and 1 would be 3, and we have nothing in this column, we carry down our 3. Our answer should be 33,072. Now, in addition to knowing how to set this out, it's also good that we are able to use our calculator. Our calculator, we punch in the numbers we're going to add first. So 32,908, we look for addition button, plus 98 plus 66 equal, and we would see here 33,072, and that is what we got. It's also important that at this level you are able to use your calculator and use it properly, because going forward in high school, calculator skills become very necessary. Let's look at question 2. Question 2 says, what is 4,270 plus 5,691 plus 252 and 19? So let's put these into our table as we have them here. So we have put our numbers into our table, and let's add. 9 and 2 would be 11, and 1, 12. We will put down our 2 and we will carry 1. Now we move to our tens column and we'll add. So we'll say 1 and 5 would make 6, 6 and 9 would make 15, 15 and 7, 22, and 1, 23. So just so that we can see what that would look like, we have 23, we'll put down our 3, next column we put our 2. So we have 2 and 6 would be 8, 8 and 2, 10, 10 and 2, 12. So if we have 12 like this, we'll put down our 2 and we'll carry our 1. Now we add 5 and 4, 9 and 1, 10. We'll put down our 0 here, and in the 10,000 column we'll put 1. Okay, let us try our calculator one more time so that we have those skills. Our first number, 4,270 plus 5,691 plus 252 plus 19 equal 10,200 232, which is our answer that we have here. So in working our problems out, please remember you have to put the things into columns. If they go into the wrong columns, then you will not get the correct answer. Please also remember your operation. So if we're adding, we should have our sign, or addition sign, plus sign, so that it can be clearly seen what it is that you are doing. Question number 3 says, what is 100390 expressed in words? In order to answer this question, we have to understand what place value is, and we have to fill in our place value chart. So this is saying that we have one group of 100,000, no 10,000s, no thousands. We have three groups of 100, 9 tens, and no ones. So we remember that when we're saying our number, all of the thousands, we say all of the thousands first, then we say the 100, tens, and ones. So how many thousands would this be? This would be 100,390. Okay, so let's put that into words. So that would be, so this is 100,390. Again, 100,390. Number 4 says take $134.86 from $500. Now, in addition to the place value grid that we have used before, there is another side to the place value grid. This side deals with the fractional side, or the decimal side. So after we pass ones going to the right, we have a decimal point, and beyond that we deal with parts of something. So in the first column we have the tens, so whatever it is that is there will be out of 10, and going to the right of that we have hundreds, and it's the same thing. Whatever figure we see there will be how many things out of 100 pieces. And we have thousands, which is not shown here, but it will be how many pieces out of 1,000. Okay, so just like a regular fraction, where if we had a half, it means 1 piece out of 2, or we had a third, it would be 1 piece out of 3. Similarly here. So in this case, in case you're looking at now and working at, we have 500, right? So we have our decimal point, which is indicated here by the red dots, and we have, so let's go now with our subtraction. Now we would do this just the same way we would subtract under normal circumstances. Alright, please remember that we have to put things in the correct column. So we're going to start from the right and we move across to the left. So here we're trying to say 6 things from 0. Can we do that? No. So we would need to go to the next column to take, but there's nothing there, and the next column nothing there, and the next column nothing there. We go all the way to the 5, and we will take 1 from 5, leaving 4. We'll bring that 1 here, and this is one set of 10 because our system is a decimal system where we deal with groups of 10. So we're taking one group of 10 and putting it here. Since there was nothing there, this now becomes a group of 10. Okay, and we would go back to our hundredths column, and we recognize that we still can't do anything, so we would go all the way back to where the 10 is now, take 1 from that, leaving 9, take that one set of 10 and bring it here, and we would continue until we get to where we want. So can 6 from 0, not there yet, and this is how we're used to it, and we will bring it here. Okay, so now we have 6 from 10 would leave us with 4. You could simply call yourself 6 and count until you get to 10. So 6, 7, 8, 9, 10, 4. You have 8 from 9, and that would be 1. We have 4 from 9, that would be 5. We have 3 from 9, that would be 6. And we have 1 from 4, which would be 3. And all of this part over here would be our dollars, and the decimal side would have been our cents. Okay, so our answer would be $365.14. Using our calculator, we will verify our answer. So we will punch in 500.00.00, and we're going to look for our subtraction button. We're subtracting $134.86. We hit our equal sign, and here's our answer, $365.14. Number 5, we have 5,348, and we are subtracting 999 from that. We have moved away from the place value grid that we were using before. We should be able to easily identify these. So the 8 would be in our ones or units column, 4 in our tens, 3 in our hundreds, and 5 in our thousands, and so on. So if we have 8 things, can we take 9 from it? No, because 9 is more than 8. I'd have to take 1 from the 4 in the tens column, leaving 3, and that one set of 10 with the 8 now becomes 18. So now I can take 9 things from 18, because 18 is more than 9. And we could easily count from 9 until we get to 18. And if we know our timetables, we will know that 9 twos would be 18. So if we take 9 from 18, we'll have 9 things left. We move to our tens column and we'll do the same thing. We have 9 here, which should be taken from 3. But can I take 9 things from 3? No, I need to take 1 from the column beside it, the column to the left of it, which would be our hundreds column, and I'll have 2 things left here. One set of 10 with the 3 would now make 13. 9 from 13, 9, 10, 11, 12, 13, that would be 4. And I'll do the same thing for the hundreds column. 9 from 2, can't. So I'll take 1 from the next column, leaving 4 in it. And 9 from 12 would leave us with 3. I have nothing to subtract from the 4, so I will put it back. So my answer here would be 4,349. To verify with our calculator, we would enter our subtrahend first, our minuend first, which would be 5,348. Then we would subtract our subtrahend, which would be 999, and our answer, which would be called the difference, is 4,349. Number 6. Number 6 says 4,321 multiplied by 5. So we're going to start now, and we'll say 5 ones would give us 5, 5 twos would be 10. We'll put down our 0 here and carry 1. We'll say 5 threes, 15, and 1, 16. We'll put down our 6 and we'll carry 1. We'll say 5 fours, 20, and 1, 21. We'll put down the 1 exactly in that column and put the 2 in the column beside it. Let's count off 1, 2, 3, comma. So this would be 21,605. calculator skills, clear our calculator, and 4321, 4321, hitting our multiplication sign now. By 5, factor by factor would be equal to our product, 21,605. Number 7. Number 7 says 3.74 multiplied by 1,000. There are several ways we can do this. One of the easiest ways is to say 1,000 multiplied by any decimal. We would simply move the decimal point 1, 2, 3 places to the right. So that would be 1 place, 2 place. You have to put a 0 here in order to get 3. So our new number would be 3740. Then you'd have the decimal point. So our answer, this would be 3,740. Another way of working this out is by saying 3, 7. Let's fix this 7. Three, 7, 4. And we multiply by 1,000. Okay. And we should end up with the same answer. So let's see. 4 times 0 would give us 0. 4 times 0 is 0. 4 times 0 is 0. And 4 times 1 would be 4. And why we say 370, the theory behind this is that we should treat our decimal 3.74. We just take off these, we put the decimal point away for now, multiply it as a whole number, and then later we add them back. So put a placeholder here and we start multiplying in this column. 7 times 0, 0, 7 times 0, 0, 7 times 0, 0, and 7 times 1, 7. Now we move to the 3. It's in the hundreds column, so we put 2 placeholders and start multiplying. 3 times 0, 0, 3 times 0, 0, 3 times 0, 0, and 3 times 1 would give us 3. Not a pretty 3. Okay. Let's get a better 3. Good. Let's add. So we'll have 0 and 0 in this line, 0, 4, 7, and 3. Now going back to our 3.47, make it clearer here, 374. Let's remove this one. This has 2 places of decimal. So if we're going to multiply it without the decimal points, let's come back and put those 2 decimal points in. So here we have 1 place and 2 places of decimal. So now if we notice 3740.00 is the same as this one, because our decimal places here are not being shown, but if they're not being shown, it would just be zeros, right? So our answer is still either way 3,740. Okay, so it's much easier to do it this way by just moving the decimal point 3 places, right, than it is to actually work this out like this. So once again, 3.74 multiplied by 1,000. Short way of doing it is moving this decimal point 3 places to the right. 1, 2, add 0 and 3, and then you write 3, 7, 4, 0, and our decimal place would be here. Alright, so that's a short way of doing it. Number 8 says 108 divided by 9, and here we have our memory tool. We have every duck must swim back, which is the same as saying we can estimate, divide, multiply, subtract, and bring down. First we would say 9 into 1, that can't work. We say 9 into 10, that could work. 9 could go into 10 one time. 1 multiplied by 9 gives us 9, then we subtract, we get 1. We bring down our 8. Then we say 9 into 18, that could go 2 times. 2 times 9 would give us 18. 18 from 18 is just with 0. We could double check our answer by multiplying the quotient and the divisor to see if we get back the dividend. So in this case we say 9 twos will give us 18, carry 1, 9 ones 9, and 1 10. So if we get it back, then we know that it's correct. Number 9 says, what is 8,235 divided by 27? So we're going to estimate. Let us call this 30. Let's call this 30. Let's call this 80. How many times could 30 go into 80? We're rounding off to the nearest 10. So we know that 30 could go in there at least 2 times. So we're going to estimate now that 27 by 2 will give us 2 sevens 14, carry 1, 2 twos 4 and 1, that's 54. 54 is still less than 82, so maybe we could try 3. 3 sevens 21, carry 2, 3 twos 6, and 2 8. Okay, so 27 by 3 could work. So we estimate. Now we're going to divide. We say 27 into 82 goes 3 times. 3 times 27 will give us 81. We subtract, and we have 1 left. Then we bring down 3. Can 27 go into 13? Our rule says that whenever our divisor is larger than any section of the dividend that we're working on, then we add a 0. Okay, carry down to 5. Can 27 go into 135? Call this 30, and let's call this 130. Now 30 could go into 100 3 times, because 3 times 30 would be 90, and we have another 30 after the 100, so we're looking at about 4 times. Okay, so 27, no, that's 24. So let's look at Let's look at 27 by 4. 27 by 4. So 7 4 is 28. Carry 2. 4 2s, 8 and 2, 10. Okay, let's try 5. So 27 by 5. 7 5 is 35. Carry 3. 5 2s, 10. And 3 13. So this goes into it exactly. So we'd say 27 into 135 goes 5 times. 5 times 27 would give us 135. Subtract, and we have zeros all the way down. So we would have brought down our 5 or 3, we would have brought down our 5, and at the end of it it would be 8,235 divided by 27. Our answer would be 305. Let's double check that. 305 multiplied by 27. 75 will give us 35. Put down 5 carry 3. 7 times 0, 0. Bring back the 3. 7 3s would be 21. Moving to the next column. Add 0 as a placeholder. 2 5s 10. Down 0 carry 1. 2 times 0, 0. Carry down 1. And 3 2s, 2 3s 6. Let's add. We have 5, 3 here, 2, 1 and 1, 2, and 6 and 2 will give us 8. So as long as we get back our dividend, then we know that we are correct. Number 10. It says reduce the following fractions to their lowest terms. Now when we're reducing fractions, we need to find the highest common factor. Alright, so we are looking for factors that are common to both the numerator and the denominator. Okay, so what would be the factors of 8 and the factors of 10? We've done this already, but just so we're all on the same page, let's refresh ourselves. Factors of 8. So we would say factors of 8, let's put 8 at one end and we put 1 at one end, because 1 could go into 8 and 8 could go into 8. Let's close this gap now. What number comes after 1 that could go into 8? 2 could go into 8 4 times. Could any number between 2 and 4 go into 8? The only number is 3. Is it going to leave a remainder? Yes, so we couldn't use it. So the factors of 8 are 1, 2, 4, and 8. So those are the factors of 8. Okay. See if we can get this a little bit neater with our equal sign. Okay, what are the factors of 10? So we go through the same process. We'll write down 10. Let's put 10 here and fix this equal sign again. Equal. Factors of 10, we would just write 1 and we would write 10, and our aim is to close the gap. We're looking for factors between these two numbers here. Now we know that 2 could go into 10 and it could go 5 times. We have 3 and 4 between these two numbers. Can 3 go into 10 without leaving remainder? 4? No. So the factors of 10 are 1, 2, 5, and 10. So the highest common factor would be 2. Right? So let's use 2. 2 could go into 8 4 times, and 2 could go into 10 5 times. So our answer for 8 over 10 would be 4/5. So similarly, we would look for factors of 15 and 45. Okay. In this case, we use 5. 5 could go into 15 3 times, and 5 could go into 45 9 times. We could still go down further with this. We could say 3 could go into 3 one time, and 3 could go into 9 3 times. In fact, if we look closely, we could say 15 could go into itself one time, and 15 could go into 45 3 times. However, some people are not going to be used to using big numbers like that. But even if you use a smaller number, all you need to do is make sure that you bring it to the point where it can go no further. Okay, so 12, in this case, we know that 12 could go into 12 one time, and 12 could go into 108 9 times. So our answer here would be 1/9, and our answer here is 1/3. Okay. Number 11 says, what is $61.84 plus $27.96 plus $203.07? Let's add. 6 and 4 would make 10, and 7 would make 17. We put down our 7, would carry 1. We could say 9 and 1, 10 and 8, 18. Put on our 8 and carry 1. We could say 7 and 3 would make 10, 10 and 2 would make 12, carry 1. We could say 2 and 6, 8 and 1, 9 and 2. We have our decimal point, which we'll put back there. So our answer should be $292.87. Let's check that. We add $61.84 plus $27.96 plus $203.07. $292.87. Okay, question 12 says, a newspaper vendor sold 265 newspapers on Monday, 315 on Tuesday, and 496 on Wednesday. How many did he sell in all? So what I've done here, I've put a day of the week, the letter representing the day of the week. So on Monday he had 265. On Wednesday he had 315. On Thursday he had 496. Alright, so what we're going to do, we're going to add all of these and we'll see what he gets. So 5 and 5 would make 10, and 6 would be 16, carry 1. 9 and 1, 10, 10 and 6, 16 and 1, 17, put down 7, carry 1. And 4 and 3, 7, 7 and 2, 9 and 1, 10. Okay, so it will be 1076 or 1076. Okay, it says for number 13 that oranges are sold at $24 per dozen. What is the cost of one orange? Now we could work this out as a simple ratio. We could look at the cost for a dozen oranges. We have $24, and they ask us to give us the price of one. So if they're asking us for one, we would need to state how many things are in a dozen. Okay, so there are 12 things in a dozen. We want to know the cost. We'll call it x of 1. So this is a simple ratio, and in this case we could cross multiply to find our answer. So we could multiply 12 times x and we will get 12x on this side. Put our equal sign, and we say 24 times 1 would give us 24. Now in order to find x, we need to divide this side by 12. So 12 will cancel 12, and we divide the other side by 12.
So when we have cancelled on this side, we'll be left with x being equal to 12 into itself one time, and 12 into 24 goes 2 times. How many times can 1 go into 2? It can go in there 2 times. So x would be equal to 2. What this is saying is that if I use $24 to pay for 12 oranges, I will use $2 to pay for 1. Let's double check that. A dozen multiplied by 2 will give us back our $24. Okay, so that's what was said originally, that this statement is true. We have $24 and we get a dozen oranges for it. So we have a unit cost of $2 per orange. Okay, number 14 says at a concert there are only seats for 365 people. If 560 people were at the concert, how many did not have seats? So we need to subtract. So 560 persons showed up, but there were only 365 seats. Subtracting, we can't take 5 things from 0. We'll have to take 1 from the 6, leaving 5. 5 now from 10 would leave 5. 6 cannot be taken from 5, so we'll take 1 from the 5 next to it, leaving 4. That one coming over here becomes 15. So 6 from 15 will leave us with 9, and 3 from 4 will leave us with 1. Our answer, 195. Number 15 is asking us how many times can 6 go into 54. Here we have to our right, we have a copy of our 6 times table. So we would say 6 times 1 is 6, 6 2s 12, 6 3s 18, 6 4s 24, 6 5s 30, 6 6 36, 6 7s 42, 6 8s 48, and 6 9s give us 54. So what this is saying is 6 times 9 gives us 54, or 6 into 54 could go 9 times. So to show this here, we're supposed to say 6 into 5. That can't work. We'll put 0 here. We would subtract. We would put down 5, and then we would bring down our 4. Now we would say 6 into 54. That can go 9 times, and we multiply now. 9 times 6 would give us 54, and we would subtract, and we would get 0 there. So our answer should be 9. Number 16 asks us to identify what the underlying digit is in terms of its place value. Okay, so what is the place value of the underlying digit in the numeral listed below? And here's the numeral. Here's the number rather, 28,465. If we put it in our place value chart, we'll see that the digit we're interested in, which is our 8, falls in our 1,000 column. So this should be 8,000. The value of it, 8,000s. Okay. Number 17 says, what is the difference between 1.85 and 18.5? Got some interesting responses here, but let's do it the proper way, please. When we're finding difference, all that is saying is that we need to subtract. We put a larger number, which is 18.5, to the top, and a smaller number, which is 1.85, to the bottom. So let's go through this. If you notice here with our 18.5, subtracting 1.85 from it, there is a missing digit that would be here. Technically, this would be our 10th column and our 100th column. So we would need to put a placeholder here, and we begin. We're subtracting. So 5 from 0. If I have nothing, I can't give you 5 things. So I'll have to take some from somewhere else. In this case, I take a set of 10 from the 5 that is here. I bring it over, and now I can take from that. 5 from 10 will leave me with 5. 8 from 4 still can't work, so I'll need to do that again. I'll take 1 from the 8, leaving 7 there. I'll bring that set of 10 over, and it will make 14. Okay, so 8 from 14, I will call myself 8 and count until I get to 14. So I say 8, 9, 10, 11, 12, 13, 14. I get 6. Carry down my decimal point, and I say 1 from 7 will leave me with 6, and there's nothing here, so I carry back down my 1. So my answer here should be 16.65. I can use my trusted calculator to double check my answer, and in this case I will punch in 18.5 minus 1.85. Hit the equal sign, and 16.65. Okay, so please remember, when we're using the calculator, we have to pay attention to where the decimal point is. Hit the decimal point at the appropriate time. Calculator skills are important. Number 18 asks us to add the fraction 2/5 plus 3/5. So we have it set out here. If the denominators are the same, we simply add the numerators and keep the denominator the same. So we would say 2 and 3 would give us 5 over 5. Now 5 over 5, how many times could 5 go into 5? 1 time. So it would be, our answer, 1 whole. Number 19 says 2.5 minus 1 1/4. Okay, so we could change our mixed numbers here to improper fractions. So we would say 2 times 2, 4 and 1. This would make 5 over 2 minus 4 times 1, 4 and 1, 5 over 4. Now we need to find the LCM, lowest common multiple, which in this case would be 8. We say 2 into 8 goes 4 times, and we use that 4 to multiply the numerator. So 5 4s would make 20. We are still subtracting. 4 into 8 goes 2 times. We use that 2 to multiply the 5. 2 5s would make 10. So 20 taking out 10 would leave us with 10 over 8. Let's correct this. This would leave us with 10 over 8. So 10 over 8. Now, if we have 10 over 8, we could use 2 to reduce. We could say 2 into this will go 4 times, and 2 into this will go 5 times. Now we're left with 5 over 4. Alright, equal sign. Now we could go even further and change this improper fraction to a mixed number. 4 could go into 5 1 whole time with 1 remainder over 4. So our answer should be 1 1/4. Number 20, final one, says complete the statement. Factor by factor equals to, and that would be equal to our product. Factor times factor, product. For example, 2 times 8 would give us 16, right? So one factor is 2, the other is 8, and the product would be 16. So factor by factor would be equal to product.